let us see this resonance and its their applications and all that. In that, let us also see how exactly the resonance is taking place. In this resonance, we have seen there must be three conditions must prevail. One is pi conjugation, another one is pi p conjugation, and the third one is pi charge conjugation. While writing the resonance structures, we must take care certain things like, for example, if there is a minus charge is there, minus charge is coming. This is the way you have to write it. If the plus charge is there, the pi bond is giving. So, what you understand here, the minus charge is more rich than the pi bond, that is why electrons are moving from that side to this side. Here this is the deficiency, therefore, the pi bond is happens to be rich than the positive charge. Therefore, according to the certain observations, you can make like this, electron flow will be like this, or richness. In fact, the minus charge is more rich than the a non-bonding or a pair of electrons than a pi bond, than we can take a free radical, than a positive charge. So, this is the way electrons move from this side to that side. That means a minus charge can give electrons to the pi bond, isn't it? A lone pair can also give electrons to the pi bond. A pi bond also can give electrons to the pi bond. So, this way if you write electrons flow, that is right. If the pi bond is giving electrons to the positive charge, it is okay. This is also allowed. And if a pi bond is there, if a dot is there, and the sharing will be there, and another system, if a dot is there, it is not actually donating, but one electron from that side and from one electron from this side, one electron goes this side. So, therefore, you cannot say that the pi is giving electrons to the dot, but dot and pi shares, and the consequent structure will be forming. So, that is from which side to which side electrons flow must be taken care, and accordingly we have to propose the structure or write the structure. Similarly, already we have referred one point, the resonance is going to give the stability, and how much stability in terms of resonance energy, we have a method of calculation also we have seen. And now we will see all the times the resonance stabilization will not be same. Sometimes stabilization will be some little bit better one, or sometimes will be less. So, as per this resonance stability, the resonance can be divided into three different types of the resonances. Let us see the types of resonance. The number one type, we can call it as a no charge resonance. You too can call it as a grade 1, or you can say the best type of the resonance, the best variety of the resonance. One example of this category is benzene, for example, has 3 double bonds. If this double bond comes here, this goes here, and this comes here, another structure is formed, and in which the double bond positions are shifted. Now, the structure 1 and the structure 2, none of them have the charges, and this is the best variety of the resonance. That is what I said, it is the best resonance or grade 1 type, and it gives the most or the more stabilization factor. Second one will be the charge is there but it is rotating, we can say it is called charge delocalization. Already charge is there, we are not going to create it, but charge is there already. For example, a vinyl attached with a carbocation. Charge is a problem, but the charge is going to be shifted to the other side. So, first one is having charge, second one is also having charge. So, the position of double bond is changed, that means the reactivity of the double bond is decreased. The positive charge is the problem, the problem is shifted one place to the other place or shared, so therefore the problem is reduced. Either way you can explain that the allyl carbocation has become stable. But the stabilization when compared with this one, it is not like this. So, this you can say grade 2 type. Grade 2, or you can say comparatively it is the better resonance, it is not the best resonance, but it is the better resonance. The third one you can say charge separation. Charge separation, that means original one has no charge, a smaller molecule like vinyl chloride, let us take. Vinyl chloride has no charge, or butadiene has no charge, but when you write the resonance structure, the lone pair is rich, therefore this is giving and this is taking, so therefore this side you will get a charge, that is minus charge you will get. Other side you will get a positive charge, because the chlorine has become double bonded, one lone pair is lost, so therefore you will get a minus. If the minus is given back, once again you will get back the original one, right. So, these two structures, if you carefully observe, the first one has no charge, has become into plus minus, that is a neutral one is divided into the plus and minus, a unification again charge. In this case, this will be always in number little more than that one, because this is a neutral one, that is impartial type of percentages will be there. So, you too can say like this side more will be going, that side will be less will be going, isn't it? But this is a symbol for the equilibrium, therefore, but the information can be shown like that. So, neutral side will be more and a charge separated is not that better encouraged. Here both are identical, so 50-50 contribution will be. Both are identical, 50-50 contribution. So, when a neutral one is showing with the charge separated, the two will not contribute equal amount to the original structure. This contributes more when compared with that one, okay, right. But still this is also gives a double bond is localizing, therefore reactivity decreases and the stability increases. Let us call this one as a grade 3 type of this one. Books may not give this information like grade 1, grade 2, grade 3, but nothing wrong to say that best resonance, better resonance and good resonance. There is no bad resonance as such, because the resonance is itself is a positive, that is a phenomena, always stabilizes, there is no destabilization. Sometimes the best stabilization, sometimes relatively little lesser stabilization, much more little, but still it is stabilizes. When compared with a molecule with no resonance and charge separation, this is somewhat better. But there is always a chance that a molecule right now is having a, let us say, charge separation, it want to become into the second type, or it want to become into the grade, that is upgradation. So, a person having no job will have a right to get the job, but already you got a job, let us say the grade 3 job is there you are doing. So, you have a right to chance go to the grade 2 to grade 1, upgradation of the job. Like that here also, a molecule having a lower grade will try to get the upper grade resonance by losing some proton or gaining some parts or something like that. Internal change of the structural change will leads to give another type of the delocalization. Let us have one or two examples. Actually, this resonance phenomena is mixed with the another phenomena, the third phenomena called mesomeric effect. and most of the applications this and that you cannot exactly separate and say this is the purely the resonance or this is the purely mesomeric effect. Therefore, most of the examples we cover under the mesomeric effect.